Let's start with the first one. Find u times the dot product between u and v, between u and u, and the length of u squared, the dot product between u and 3v. So this is just exactly using the rule. Be careful on the last one. You have to find the 3v first, then multiply u by the result, by the new vector. The same thing here. Find the dot product between u and v, and the result, you're gonna do the dot product with v. Okay? So let's go to the second one. Exactly the same thing.
Wait, so
Yes.
I've been doing this one and I just can't figure out D.
D. It says find the dot product. What it says D? If you go back to the theorem, go back. Let's go back to okay, that's it. So how you doing this example here?
Yeah, D. I tried that one and I answered it many times. Just can't.
Okay. So here's the thing. So here's the dot product of u and v. U equal, tell me the vector u is 5, 11.
Did you put parentheses around it, Raymond?
Yeah, I did. I got all the other letters right, but
Here's the thing. I need you to tell me how you did that. -2 and 3.
well,
So
I did it.
u times v, how much the result? 5, it's going to be -10 plus 33, right? And the result is going to be 22.
Yep.
So u times v with the v is going to be look like what? 22 times the vector v. Yes or no?
Yes.
So it's going to be what? It's going to be -44 and what? 66.
Oh, I see what you're saying.
You got it? Because why? Because when you multiply the dot product of u and v, the result is a scalar. See, the result is a number.
All right, I get it.
And when you multiply the number by the vector v, so you have to include the scalar, okay? The same thing here with this one. You're going to do exactly the same thing here. With this example, E, be careful. You have to multiply 3 with the vector v first. You're going to get a new vector. Then the new vector, you're going to do the dot product with the u. Okay?
All right.
Next one. Exactly the same thing here.
That's the same.
But the only difference is how they give you the vectors. This is with the standard form. This is just regular one, you see? So exactly the same thing. Find the angles theta between the vectors in radian and in degree. How are you going to find the angles? Cosine theta is going to be the dot product between u and v, and divided by the length of u and the length of v. This is the rule. So the dot product between u and v is going to be 1 times 2, 1 times 2 plus 1 times -2. So it's going to be 2 minus 2, and it's going to be equal 0. So the dot product is 0. So how much the theta?
It would be
90 degrees, right?
9 degrees. So here I'm going to write down, how are you going to find the symbols?
If you just type in pi, it will translate it.
Type pi, like pi.
Yeah.
Oh yeah, perfect.
oh yeah.
So pi over 2. Pi over 2. And the degree is with 9. Yeah, here's the sign. Next question. The same thing with this one. They just give you different type of angles, different type of vectors, which is in standard unit vectors. Find the angle between the vectors in radian and in degree. U is going to be cosine pi over 3i plus sine pi over 3j. And V cosine 3 pi over 4 and sine 3 pi over 4. How are we going to work on this one? We're going to do exactly the same thing, but be careful. Careful with the angles. I think this is going to be the hardest one. Okay. Let's go to the next one. Use the alternative form of the dot product to find U times V. They give you the theta, so you're just going to say cosine of the dot product U times V is going to be the length of U times the length of V cosine 5 pi over 6. So U times V is going to be the length of U, which is 10, times the length of V, 20, cosine 5 pi over 6. So it's going to be 200 cosine 5 pi over 6. And how much is the result? This result is going to be negative, positive.
I'm trying to think on the radian circle.
Mhm.
It would be negative, that's for sure. 6 over 6. The coordinates are like, and it's been a while since I thought of the radian circle. Oh, wouldn't it be root 3 over 2? Negative root 3 over 2?
So 5 pi over 6. How much? How much the angle? 5.
Oh, the angle.
Yeah, pi over 6.
That would be minus 15 on 90, 180, minus 15.
No, it's going to be 180 minus
165 degrees?
minus 30.
Oh, minus 30. That would be
Yeah.
150.
So it's going to be how much the square root for 30 in the second coordinate.
Second coordinate. Well, the second coordinate. Oh, wait. That would be the y coordinate, wouldn't it?
So here, like this. You walk in, it's the angle is 150. So 150, let's say here, okay?
Mhm.
So it's going to be 180 minus 30. So we're going to work with this one. Here is all sine, cosine, and tangent is positive. Here is the sign is positive. The cosine is what? Negative.
Mhm.
So that means it's going to be negative square root of 3/2.
Yeah.
Because it's going to be negative. The cosine on the second coordinate is negative. That means the result is going to be 200 times negative square root of 3/2. And it's going to be negative 100 square root of. Okay?
Mhm.
Can you tell me the formula for finding the length of the vector? I can't.
The length of the vector, like for this vector. Let's say 3 and 2. So it will be square root of 3 squared plus 2 squared. Okay? That's me. I'm talking about this vector, okay? The first component square plus the second component square. Okay?
Yep, thanks.
You got it?
Yes, got it.
So let's check this one is negative 100 square root of 3. Yes. Determine whether U and V are orthogonal. How are you going to check U and V are orthogonal? Parallel or neither? Who's going to tell me? Now, if you want to check U and V are orthogonal, how are you going to check that?
Find the dot product.
The dot product. Okay. If the dot product, you get the dot product equal 1. How are you going to check it's parallel?
Unit
How
vector.
are you going to check it's parallel? We already did that. I'm going to give you a hint. Remember when I told you, if you have U and V, U is parallel to V if you find you have C such that U equal C times V. Okay?
Yeah.
You got it? So this is how to prove it's parallel. So if it's not orthogonal, go ahead. Can you try this one? If you find a C, that means this is parallel. If not, that means you're going to choose neither. Okay? You're going to do that exactly the same thing with this example, 9. Let's see, consider the phenomenon. Find the projection of U onto V. Projection of U onto V. Let's do this example. Yes, go ahead.
What's the equation for two vectors being unorthogonal again?
On the orthogonal, like this one?
Yeah, how do you check that?
How are you
Again?
going to check that? Okay. How are you
Neither.
going to check it's orthogonal? You have to do the dot product.
Oh, the
So,
dot. Oh,
yeah.
okay.
Like,
Needed
the
to memorize it or something.
yeah, the vector U is going to be 0, 1, and 6. And the vector V is going to be what? 1, -2, and -1. Total product U times V is going to be 0 times 1, 0, plus 1 times -2 is -2, plus 6 times -1 is -6. Is the result equal 0?
No,
No,
it's
the result is equal -8. So it's not orthogonal. You're gonna go ahead and check the parallel. Let's check the parallel. Can you write down? So it's not orthogonal. 0 equal C times 1. That means C is going to be equal 0. 0, the second one is 1 equal C times -2. That means C is going to be -1/2. The third one, 6, is going to be equal C times -1. That means C is going to be equal negative. Is that the same C?
No.
No. What does that mean? It's not parallel. So you're just going to choose neither. Okay?
Uh-huh.
Same thing you're going to do with this one. But now these with the cosine and sine. But you're going to do exactly the same thing. Find the projection. Let's do this, the last one. How to find the projection? So U equal 3, 9. And V equal 4 and 4. So the projection, which is W1, projection of, they're telling you of U onto V, of U onto V is going to be equal. You have tools. Which one you're going to use? It's up to you, but be careful. Remember, I told you can use this one, or you can use this one. Dot product. So projection of U into V is going to be V times U, dot product over V times V times the vector V. On the side, V times U, the dot product between these two. 3, 4 times 3 plus 4 times 9. So it's going to be 12 plus 36. So it's going to be 4, 8. So this is the dot product between V and U. Between V and V is going to be 4 times 4 plus 4 times 4. So it's going to be 32. That means the projection is going to be 48 over 32 times the vector V. How much 48 divided by 32?
Divided by 8, both numbers would be 6 over 3.
6
No,
over
6
3.
over 4.
6 over 4. That's means 3 over 2.
Yeah, that's 3 over 2.
Huh? So 3 over 2 times the vector V, which is 4 and 4. So the projection is going to be, cancel this one with this one. So it's going to be 6 and 6. Okay? So this is W1. To find W2, which is the second part of this equation, find the vector component of U orthogonal to V. So the W2 is going to be U minus W1, which is equal U 3 and 9 minus 6 and 6. So it's going to be -3 and 3. That's it. And to prove that, if you multiply W1 times W2, the result is supposed to be 0, because they are orthogonal. W1 times W2 is going to be W1 6 times -3 plus 6 times 3, and it's going to be -18 plus 18, and the result is going to be 0. That's a proof that W1 is orthogonal to W2 because the dot product between these two equals 0. Okay?
Wait, A is like is running W1 and B is running W2.
Oh yeah, because W1 is the projection.
Okay.
Okay, W2, if they ask you to find the vector component of U, which is W2.
Mhm.
Okay,